at the 2022 Automate Conference. Metro Detroit. It is packed. Almost no one has a mask on. Too big masked up. Civil liberties here, so COVID numbers down. Relatively high case count, but hospitalization and death is rather limited. So surprised how packed this is. Huge conference here, automation conference, largest automation conference in North America. Travels around this year in Detroit. Not sure how large. I'm surprised. I didn't realize it was going to be this packed, but great. So I'm here. So get loaded some of these computers, automation. Last week I was at 2 weeks ago, the injection molding conference, and Michigan's one of the leaders in injection molding, making molds and injection molds themselves.
Follow me over onto the other side of the Honeywell booth by this big red wall.
Detroit is also
And we will start our
one of the global
shortly.
leaders, so the national conference that travels around this year is in Detroit. So we should see some awesome technology demonstrations. I'll try to walk around, cover the majority of the floor, see some demonstrations, and then I'll try to pick up some reading material. Conference is going through Thursday, so anybody in Metro Detroit, come down, check it out. The conference you have to pay for, it's kind of expensive, as where the convention is free. I believe you could register online or on the spot, and a whole bunch of automation demonstrations, a quick simple suction cup taking place, all different sorts. So I was at the additive manufacturing, the 3D printing. 3D printing is a minor form of automation, is where 3D printing, as I said, usually has one head that moves on an XY axis and has an extruder and then a platform. So usually a 3D printer doesn't even operate on an XYZ axis. It only operates on an XY axis, and the Z axis moving up and down is done by moving the whole plate that it's on. So robotic arms have what they call degrees of freedom, which is the type of rotation that the robotic arm does. So, but here they have 3D printers here also. So instead you have the platform. Hey, yeah, awesome. Thanks a lot.
Hey, how you doing? Good. Good.
So you have the platform that does the Z. So it only has one moving part connected to an extruder that moves along the XY axis, and then the whole plate on a different arm moves up and down on the Z. So here, for example, this one would appear to have 3 or 4 degrees of freedom, meaning parts where the whole thing rotates. On the bottom it rotates, then there's a arm that goes up and down, and probably another arm and another rotation. So in order to reach the desired position, there's multiple axes that could turn on. And so you can see the various arms and how it rotates. And those are usually, I think, referred to as degrees of freedom. Like the potato and scanner, simple device. Alright, here's getting kind of shoes here. So degrees of freedom. So usually these conferences are made up of different companies. So you'll have actual robotics companies that make the robotics. You'll have the connected software, possibly material design company, integration, other related industrial companies, and a lot of the bigger companies that do this are conglomerates. So, for example, the arm on a robot connects to something, and sometimes has a claw, sometimes has a suction cup. There's multiple different ones. So there's just a suction cup, for example. A lot of them have a claw, and there's multiple different type claws. And you could even have like a screw. You could have paint. Anything could be at the end of the robotic arm. And robotic arms usually operate either hydraulically or electrically. Hydraulically meaning air pumps, that the movement is caused through air pressure, and electrically through electric. And so some robotics are designed for either way. So, hey, God bless you, okay? So, just trying to walk around, get a feel. I think almost half of the show was taken up by the conference here. Robotics has all different sorts. So here you have a basic claw in motion, simple machine, a few degrees of freedom. So there's multiple methods for programming a robotic arm. Some of the newer robotic arms could be trained. So there's intelligence, there's machine intelligence robotic arms, and then there's trained robotic arms. And most automated arms do the exact same thing every time. They do something and then they repeat. And for automation process, that could be thousands of times, millions of times over its lifetime. They know exactly what they want it to do, and it does it again and again and again, like an automation process. So if it was related to injection molding or something, just take the piece and put it, or a part, a machine outputs a part, and then they simply want the part put into the next process. It could be a conveyor belt, and it could be multiple processing. So it could be a machine has multiple levels of processing. So first that the part will enter a machine, something will be done to it, then it'll be taken from that machine and moved on to the next machine. And there could be multiple processes. It could have like an automation plant, like a car. You could have hundreds of stops along it. To a simple manufacturing process could have 2 to 5, 10, any number of parts. Rarely are they all automated. You could conceivably have it completely automated, but usually they work together with man and machine, and you'll have people that will take the part and move it manually or fit it into the machine. So if you have a machine that's doing a purely repetitive process, that all it does is repeat the exact same movement over and over again at the exact same scheduled time. So if a part releases a machine, and some of these operate very fastly. A part, machine releases the part at every time interval, and then the machine takes that part and moves it to the next one. And those are pretty difficult to program. Configurable manufacturing, where you would have it exactly timed. So most machines are intelligent, which means they have some sort of sensor, and the sensor guides them when to do it, that it's triggered by a sensor. So there's multiple types of sensor. It could be visual, pressure, could be weighted. So if it's moving on a conveyor belt, that it triggers by like a pressure or weight sensor. or a visual sensor, and that will indicate when the machine should take the part. And there's a special programming language for computers. Usually it's connected to a PLC circuit. So there's a suction cup, 4 suction cups. So some of these, like Allen Bradley's a big company. I think Johnson Control and Allen Bradley are the same company. There's a special programming language for robots, and it's mostly geometric physics. So I said that besides getting the simple plane on an XYZ axis, and if it's triggered, whatever it does, if it has a single amount of pressure or strength, or if it operates. So how do you get it to the XYZ coordinate? And as I said, it has multiple degrees of freedom in terms of moving parts. It could have multiple different arms that move. So what arm is going to move in order to get the piece to the part? Coordinate the movement of the machine arm with where it wants to go. So this will be in high D later, so I'm not sure how good the reception is, but after I'm done recording, I will upload it in high definition. So all different types of, and I'm just walking around. I didn't prepare that much. I didn't realize how big it was going to be, so I might even come back tomorrow or Thursday. So if you want to program how it gets to its place, there's multiple points of movement. For example, like the arm kinkle. Someone thinks tuning in. So like, you could move your elbow, your shoulder, your wrist. There's different coordination of movements that you could do to get the piece to the exact same part. So programming a robot has to program all the various degrees of freedom, rotational parts for its access. So you could have machine intelligence, you could have it coded where the machine does exactly as it's told, and how it gets to where it goes, and what arms it moves, when it does it is all coded. And it said that could be repetitive on a time. So you have a whole bunch of big CEOs, a lot of millionaires, a lot of big companies. Some of these companies employ tens, hundreds of thousands of people around the world. So here's like a PLC circuit that would control a robotic arm that would have some of the code. So it could be coded with exactly the method that the computer, that the machine's going to use. If it's measuring a pressure sensor or a visual sensor, when it's going to go, or for the exact time, or if there's some coordination with another machine where the other machine tells it the part is ready, and from there it coordinates with it. Or most of these now have some sort of machine learning. So that could include how it gets to the point where it wants to get. So here, we're just picking up with the suction cup and putting it down, then a new one. So here also, see there's multiple boxes on the table. So just as a mathematical problem, it's going to pick up one of the boxes and it's going to move them to a sensor. So it probably has some form. It could be a complete program where the program has told it to pick up boxes in a certain order and place it. Or it could have a guided sensor and some sort of machine intelligence that would be pre-programmed into it that would allow it to, so to say, make decisions for itself based on its program. Where where it would use its sensor. Very good. It would use its sensor to determine where the object is, and then it would use some sort of programmed visual analysis to determine where to place it. And so that would be connected in the circuit board. So, you know, Funak is one of the huge robotic companies that has thousands of various robotic arms. You see the degrees of freedom. So the main companies here are the robotic arms, and then the programs, the computer software to control the robotic arms, and then you have what's called the PLC circuits that connect the power circuits, logical circuits that connect and control the robotic arms specifically designed for manufacturing facilities. And then there's a lot of related companies that make like sensors or arms. So here you see a clip, simple clip arm. You could have magnets. You could really put anything on the end of an arm. And a lot of these robots are plug and play, like a CNC machine or a molding machine that you could take. You get the robotic arm, you purchase the robotic arm. It might cost thousands, tens of thousands, hundreds of thousands of dollars for the robotic arm. So like ATI, I think they're actually a local Michigan company. Like Funak, the robotic companies, they have thousands, maybe tens of thousands of various robotic arms that cost thousands, tens of thousands, hundreds of thousands of dollars, depending on their degrees of freedom, accuracy. And you can have large robotic arms, they'll have specifications. So what type of specifications, power, how much can they hold, how accurate are they? Like Shunk is one of the huge makers of robotic arms. Funak, Shunk is a gripping company, I'm sorry, so they make a lot of these grippers. Okay. Yeah, it's pretty packed here. I'm gonna definitely, there might be too much reading material. I might have to come back 2 days, just pick up reading material. I might look over some of the material, come back and talk through some more of the technology. So say the specifications of the robot, they could be accurate to millimeters, to microns, like a 3D printer arm, extruder, some of those are accurate to microns. And so even these large mechanical robotic arms that have multiple degrees of freedom, some of them could be extremely accurate. Some of them are minimally accurate. And that is, will determine the price.
We have a wonderful lineup of presentations taking place at the Automation Show Theater. Our first presentation.
These are more, this conference is designed for manufacturers. So you don't have end robots. These are designed for people in manufacturing processes. So they're not selling robots, they're selling robotic arms that would be used in manufacturing processes. In Michigan, in Detroit. So you would have someplace else that would have conventions like that might actually sell, we'll call robots as opposed to robotic arms. And this is here in Michigan, Detroit, due to the auto industry. Even though the auto industry in Michigan is on serious decline, it's still one of the centers of international manufacturers, specifically the auto industry. And so if you want to get into the auto industry, robotics manufacturer, like I've mentioned in almost all my videos, automotive or bust. Automobile makes up almost, I think it used to be over 50% of global manufacture. So you want to get into the supply chain of the automobile. And at this point, still Metro Detroit is one of the head hubs of the automobile and the supply chain. So yeah, it's not actually robots. So here you have a polishing machine, sanders, anything could really be attached to a robotic arm. And it said you have specifications on how much weight they could hold and the accuracy. So you could have like a painting machine. Here's probably scanning, laser welding, anything could be attached to a robotic arm. There might be certain specifications of, so if it's pumping out paint or something, you'd have to attach the supply, like a 3D printer. You could call it a robotic arm. Has to have an attached extruder and a heat filament that melts the plastic filament. And so there's different robots that might be better. So I said many of these major companies make thousands of robotic arms for various things, and they have specifications for pressure, temperature, accuracy, weight load. So if you're talking a car factory where a robotic arm has to be able to hold hundreds of pounds to thousands of pounds, versus like a food plant, for your popcorn, this robotic arm, it might be able to hold hundreds of pounds, although these boxes are probably only a few pounds or 10 pounds. Most robotic arms hold a very small payload of just a few pounds. And you'll have relative accuracy probably within a few millimeters. So if you need extreme accuracy of a robotic arm, that's going to be, less than a millimeter. You're talking significantly more money, and the amount of weight load, I think the mathematical equations, it probably even has some sort of exponential decrease, where the more weight, you're going to exponentially lose accuracy. So if you need extreme accuracy and a higher weight load, you're going to be significantly more expensive. There you have motherboards. Some of these, you would have companies that would design the circuit logic. So if you had a robot, you knew what you wanted it to do, and you could hire a company to program it for you, and then you could hire a company to make a circuit board for you. So I think the electric control. So there's two elements. There's the PLC logic circuit, the electrical controls, and then there's the computer software. So a lot of times you need both aspects. You need specifically designed computer software to control it, and then you need the electrical PLC logic circuit. And so actually a lot of these robots don't actually need computer software. They're completely controlled electrically. And as I said, I think it's called G-code, or maybe that's the CNC machine. But there's a specific coding language for these electrical circuits that control the robots. So Universal Robots make some of the cheaper robots that you might buy for your household. I think so. I was earlier. I was mentioning trainable robots. So most robots are coded for, but you can have trainable robots where you would manually move the robot the way you want it moved, and then it would repeat. So that's more difficult for like these boxes. So this might be completely programmed, where it's programming the boxes where they're going to go. Maybe it has sensors. But let's say that it was going to go from one position to the next. And so you can't really do that with stacking boxes, because it's not going to the exact same position. But you could move it by hand, train it once, and then the robot would be able to repeat the process. And Universal Robots make some of the cheaper robots that do that. In order to do this, they could have it completely programmed beforehand, all the boxes, the height, the length, and the width. or it could have a machine learning program with some sort of sensors, digital sensors that help guide it through the box and help determine where to place the box, which boxes to take. So that would require intense computer software. This one's probably pre-programmed for this to pick up exactly from, but they also sell embedded sensors, and they get camera sensors, and the camera could determine the camera would determine the movement of the robot. So the robot would know where it wanted to go based on the embedded camera of where to pick up the piece and then where to place it. And that would all have to be predetermined through programming and your circuit board logic. They got the chess walk around.
If I move the station.
So they got a chess playing computer. So yeah, you could have. So if you had a chess playing computer where the computer decides the best move, and then it has to send a signal to the robotic arm to move the piece. And they might have all the squares on it. So the simple playing against it. So it looks like they have a rated game here with they have a slower game. White looks like they're down queen. Looks like they're almost going to be mated. So white's in bad shape here. Queen e2 is a mate in one threat. So it looks like white is going to be mated next move. You can play off, but it's going to be mate next move. And so we'll see how strong the computer is. Yep. Looks like forced mate in one. Forced mate in one.
You commentating?
Yeah, I'm a chess player. I saw the computer up, so I could come over and commentate. But yeah, it looks like mate in one no matter what.
Yeah, I think it's over. I think it's over.
That's me. You go here, you go here.
Yeah, so let's see, you make a move and it's going to be mate in one.
Yeah, that's checkmate.
Make a move. Let it deliver the killing blow. Oh, that's illegal. So you have to leave that. You can't move the king.
Oh, you can't?
Yeah. Just push a pawn or something.
Okay, so
Oh!
that's also mate in one. Okay, so knight takes
I didn't even
pawn
see that one.
is also mate in one. Could have played.
That's
There were three different mate
That's
in
the more
one.
beautiful mate.
Well, actually four. There were four different mate in ones
A little bit
there.
of style.
So it could have been knight to c2, or queen to e2, or queen to f3. All would have been checkmate. So here we got it doing a little dance. Got the computer arm doing a little victory dance, and now it's going to set the board back up. So just a simple demonstration of so the computer program tells the computer how to play chess, what the best moves are. The robotic arm is just taking its directions where to go from the logic, and saying that here this robotic arm has 1, 2, 3, 4, I guess 5 degrees of freedom, but you can see it's only using so the bottom one is rotating on a 360 axis, and this arm is moving, probably can't move 360 degrees, but maybe 180 degrees. And then the other thing is, and then so you two other degrees of freedom, the rotate arm and then the other arm that will change its length